Let's look at some of the OTDR setup options in a little bit more detail. The launch and tail cable will allow you to determine where the start of the trace is and eliminate the length of the launch or tail cable. The zone that it will look in is the length entered here plus or minus 10 meters, 10%. So in this case, if 150 meters is entered in, it will look at 150 minus 15 or plus 15, so from 135 to 165. Any reflective event in that range will be determined to be the zero starting point of the trace. So when we look at the trace with the launch cable selected, we'll see that the first event starts at 0. So we'll deselect that for now. We've looked at the setting the wavelengths. Refractive index is a calibration for the length of the fiber per the manufacturer's specifications of the fiber itself. End of fiber detection threshold, EOF, is end of fiber. What this means is any loss greater than the amount shown here will tell the OTDR that that is the end of the fiber. So if it sees a connector or a splice that has more than 6 dB of loss, the tester will assume that that is the end and will mark that as the end of the fiber. You need to be careful here because if you set the value too low, you can have a bad splice that really isn't the end of the fiber, but the tester will think it is the end and mark it as the end of the fiber. So for example, if I put 2 dB in this number and I had a splice that had 2.1 dB of loss, that is a bad splice. But the tester will say, oh, well, that's greater than 2, therefore that is the end of the fiber, and it will not look at anything past that splice as far as being part of the fiber under test. In manual mode, we've discussed our averaging times. So 15 seconds is good for low noise traces, especially if you're using longer pulse widths. So what I would not do is use 15 seconds and a 5 nanosecond pulse, especially on multi-mode. On single mode, you might be able to get away with that, but on multi-mode, you're going to have a little bit more loss in the fiber, and therefore your dynamic range isn't as good. Single mode has less loss in the fiber, so you could get by with a shorter averaging time and a short pulse width. For these examples, I'll be using 15 seconds and the longer pulse width, but I would also consider using 1 minute as a minimum and then going up to 2 minutes if you have fibers with additional length that have more noise and you need that additional dynamic range for averaging. Event sensitivity is, think of it like a noise filter. So what this does is the OTDR sees a lot of ripple in the trace, and the math algorithms need to determine whether that ripple is a splice, a connector, or just noise. So the sensitivity, if it's set to low, that means it will ignore a lot of noise in the trace and treat it as noise. If the event sensitivity is on high, it might see some excess noise and consider those to be events like splices or perhaps connectors. So the medium zone is kind of the Goldilocks range. If you set it to high, you're going to see everything in the trace, but you also might see false events. So the best way I would say to do it is leave it on medium, but make sure that your trace isn't noisy. Meaning that you need to have enough dynamic range, meaning you have a high enough pulse width and enough averaging to get a smooth trace. If your trace is noisy, you might need to set the event sensitivity to low to eliminate picking up false events. Distance range, you want to make sure that this is set to approximately twice the actual range of your fiber. Of course, if you don't know what the fiber distance or length is, you can shoot it once at a high scale to see just how long the fiber is, and then set it back down to a number that's twice the actual range, and then do your testing from there. Pulse width. This is the amount of power going into the fiber. 5 nanoseconds is going to give you the shortest pulse width and the shortest dead zones. 10 is a good compromise. 30 will give you even more power going into the fiber with larger dead zones. So right now we'll set it to 10. This button here will toggle between distance and time. So if we look at 5 nanoseconds or 10 nanoseconds, when I change this, that's the equivalent of 0.5 meters or 1 meter, meaning that the pulse of light going down the fiber is this long. So it just converts back and forth because some people are used to using OTDRs where the pulse width is expressed in distance and not time. So those are the descriptions of the OTDR setup configuration options.